Hi and welcome back. So, we're going to be looking at greedy algorithms and what they are, how they work, and such. So, first of all, to understand what a greedy algorithm is, a greedy algorithm is a problem-solving approach where you make the locally optimal choice. Do take note of locally optimal choice at each step, with the hope that these local choices will lead to a globally optimal solution. So your entire final solution is dependent on all the sort of previous steps that you make while picking the most optimal solution at each step. And these greedy algorithms ideally work by taking these best solutions that seem to be the best solutions in the current moment without thinking about future consequences. One of the downside to this is that it could lead to a point where your future solution is not optimal because the solutions that seemed to be optimal in the current or in your local choices could lead to a final solution that is not the one that was desirable in whichever way. So that is what greedy algorithms are, and that is the basically one of the downsides to them. An example of a greedy algorithm is what we call the coin change problem. This is when you try to minimize the number of coins that make up a certain amount that you want by always picking the largest coin first. So it could work. Even think of, you have a stack of notes and you want maybe £1,000 from $1,000 from those notes. Now you start picking. If you had, let's say, a $20 bill was the or a $10 bill was, let's say, the largest denomination that you had. So you start picking those 20s first so that you can achieve your final amount that you want as fast as you can. That is an example of a greedy algorithm. Now, talking of these greedy algorithms, we need to understand their characteristics first, right? So the first characteristic of this greedy algorithm, which is what you've already seen, is that they basically pick locally optimal choices. So they pick locally optimal choices, and so at the algorithm is going to make the best choice available at each step that it's going to take. The other thing is that there's no backtracking when it comes to greedy algorithm. So once you've made a solution, or once you've made a choice, that is it. You don't revisit any of the earlier decisions that you had made. You make a choice, you're happy with it, you move forward despite what that choice might be. Then when you talk of efficiency of this greedy algorithms, basically they're often faster, but they don't explore every possible solution there is. So they don't, which means that they don't always guarantee the most optimal global solution, right? So you could have a global solution that is somewhat optimal, but it's not the most optimal because you didn't consider every possible solution that you could have made, or every possible choice you could have made at each of the steps that you are taking. So now that we've understood this characteristics of greedy algorithms, there are a number of basically problem solving patterns we that we talk about when you're talking about these greedy algorithms. And some of these problem solving patterns, the first major problem solving pattern is what we refer to as an activity selection problem. And we're going to be looking at each of these problems in details, and looking at some of the examples in the next few videos. But the activity selection problem basically is when you're given a list of activities. Each activity has a start and end time, and what you are supposed to do is pick the maximum number of overlapping activities that someone could take from that selection array of the activities that you have. So we're going to be looking at the greedy approach to that, and why a greedy approach would work in such a situation. Now we also have what we refer to as the fractional knapsack problem. So we have the fractional knapsack problem. And what this basically is that you have a set of items with weights and values, and a knapsack basically with a weight limit. and you need to take fractions of these items. And we're also going to see a greedy approach to such, why that greedy approach would work as well. The third problem that you'd be given is what we refer to as half-man coding. And this half-man coding is basically a greedy choice in compression. Basically, you need to compress data using variable length encoding to minimize the total storage that you have. So, we're going to see how you can build a tree, which is a greedy approach to this, and why that would work in the end. Now, why would someone use greedy algorithms from what you've seen up to this point? There are a number of reasons, and first you need to understand the condition for a greedy algorithm to work. And the first condition for a greedy algorithm to work is basically a global optimum needs to be arrived or can be arrived by choosing a global optimum. That has to be the first condition. So basically, and this condition is just a greedy choice property. So it has to have a greedy choice property. And this greedy choice property that you've seen is, or you are in good conviction, that a global optimum can be arrived by choosing a local optimum. That's the first condition. The second condition is optimal substructure. Optimal substructure. And what optimal substructure is, basically a problem exhibits optimal substructure if an optimal solution to the problem contains optimal solutions to the sub problems. I'll just repeat that again. If basically an optimal solution to a problem contains optimal solution to the sub problems to that, and that is what we refer to as optimal substructure. These are the two main conditions that you need for a greedy algorithm to work. Now, it doesn't always mean, from what you've seen, basically you can notice that it doesn't always mean that a greedy algorithm rather is going to be the best solution. It's going to always work. There are certain cases when a greedy algorithm might fail, and this is because it doesn't always give the optimal solution. So especially when you have a case where a problem needs a global consideration rather than a local consideration. Such a case would be, I'll use a real world example where we talk about things such as climate change, right? So when a country, there are certain countries or certain jurisdictions that have needs for energy, so energy sources, and for them, the best solution for them to get or the optimal solution for them to get the energy they need to achieve the kind of civilization they want to achieve is by using the energy solutions that are not sustainable, right? And for them, that is the best optimal solution that they think they could. But in a global level, that is not a good solution, in that it's going to affect other countries and things to do with climate change and global warming. So now those are some of the cases where you need to have a global sort of consideration on what are the energy solutions that we're going to have, let's say for each country or globally, that are going to be best for everyone. Since a local choice for each of the countries might, where they decide to use unsustainable sources of energy, might not be good or is not good for in a global perspective. So that is a case where you find that a greedy algorithm might fail or really fails. And that is basically about global algorithm. Just to summarize, is greedy algorithms rather, they make decisions step by step based on the best current choice, and they work great for these problems that we've seen. So we've seen the locally optimal choice, not really the activity knapsack problem, the fractional knapsack problem, and half-man coding. But they aren't guaranteed to work. This greedy algorithm rather, they aren't guaranteed to work for every problem. So now in the next few videos, we're going to be looking at these problems, each of them, what they are, and what are the greedy solutions that or greedy approaches are going to take for each problem, and why a greedy approach would work in such a case. Thank you, and I'll see you on the next one.